Okay, so our 30-second challenge, I'll go ahead and share my iPad for that one. I found a 30-second challenge from just a regular website. It has 30-second challenges. I can go ahead and share. Okay. Can everybody still see? Can everybody see the iPad if I start writing here?
Yes, I can see it.
Okay, great. And today is 6/8. Okay, so 30-second challenge. We're going to start with the number 51, and I'm going to add 14 to it.
We know that's square.
Oh, it sounds like music. If I start with 51 and add 14, what would that be?
65.
Okay, and how'd you get that?
I added the 4 and the 1 to equal 5, and then the 5 and the 1 is equal to 6. So just kind of doing the 1s and the 10s together.
We'll install the flushing, and then we'll be able to bring the 3-inch vent pipe right through the roof and then do the final connection.
So somebody is having, okay, if somebody has that going on, can mute that for the background.
Oh, no, so what is
Thank you. So we have, so you can add 10s and 1s, or 1s and 10s. So you do 50 and 10, add those together, you get 60, and then 1 and 4 gets 5. So we're going to multiply that by 2 next. How do we multiply that number by 2 in our head?
I'm thinking 60 times 2 equals 120.
Mm-hmm.
Plus 5 times 2, which is 10, equals 130.
Great. Now, what you've done is you've broken up the 65 into easier parts to multiply by 2. And this can be done by using the distributive property. Okay, so you break up numbers, to do mental math, you break up numbers into easier parts. So I can do 2 times 60 and 2 times 5. So that's equal to 60 times 2 plus 5 times 2. And she said it was 120 plus 10. And the answer is 130. Okay, excellent. We're going to take 50% of 130. To practice some percentages here. How do I find 50% of 130?
You're going to take half of it.
Okay, so that's the same as half of 130. Okay, how do you get half of 130?
Divide by 2.
Okay, that's the same thing as 130 divided by 2. Excellent. How do you divide that by 2?
I would split the 100 by 2 and the 30 by 2 and put those two together.
Right, you can split it to 100, yeah. Just with that multiplication problem, we're going to use easier numbers to divide by. You can distribute with the divide by 2 over addition from the back. Okay, so you can't do it from the front, but multiplication you could do front or back. And we take 100 divided by 2 and add that to 30 divided by 2. Make things easier. 50 and 15 makes 65. Great work. So the next one is we're going to do 65 plus 7. Okay. That's equal to 72. So you can do the 5 and the 7 and get the 12, and then put that 10 onto the 6. And I'm going to do 72 divided by 8. That equals 9. And then I'm going to do a third of this. So we're getting down to easier numbers. That's 3 times 7. It's supposed to be a hard one. And then plus 6. Okay, here's one that might be a little bit harder. How do I do 27 times 2?
I would split it up again. So I would do 20 times 2 and 7 times 2.
Great. Yeah, splitting it up. So it's these are techniques that you might not have done before in your life, or you might have done it before, might not, but we're kind of getting people on the same page here so we can all do these techniques for our mental math strategies. Okay? And we can therefore use these ideas in real life so we can do math faster with the things we come across in real life. So we have 20 times 2 plus 7 times 2. So in your mind, you're going to do the 40 plus the 14. How do you add 40 and 14?
You could do the 4 plus the 1 and the 4 plus 0.
Right,
So the tens should be 54.
good. And that's our answer. Okay, so there's a couple of harder computations in there, but it doesn't look like it all was tricky. Okay, so there's our 30-second challenge. All right, so we have, I'm gonna go ahead and take attendance. So hold on a second for that. And while I'm doing that, make sure that you guys have access to, like opened up or download the subtraction handout, subtraction card sort handout from today's class on the course calendar. Okay. All right, does anybody have any homework questions or questions about Friday's lesson video that they can ask?
I had one question. I just kind of wanted to know overall if we can use like any of those methods to solve the problem. Any kind of choose how you went over the different, like finding half or whatever, or finding the decimal equivalent to solve. If we can use any of those on whichever problem. Let me pull it up. So
so let's go back to the directions there. It'd be better to do reasoning, but if you're like not sure like what to do, then I think it's okay to use any method. Yeah.
okay,
Try the reasoning ones first.
okay.
You use benchmark fractions or close to 1, close to 0.
Yeah, that's kind of what I was meaning. I just wasn't sure how to phrase it.
Yeah, no, that's quite all right.
Right, thank you.
But yeah, if you get stuck, you always have common denominators and decimals to use. Okay. Well, if you do have any questions about anything, then go ahead and feel free to send me an email, or we can do an appointment through Zoom. Going on to our today's lesson, I'm going to share my iPad screen again for a little bit. And then we'll do an activity. First, we have what we're doing today. Math 2010. We're on section, we'll do I meant to say unit. Unit 2, section 6. Okay, and we're going to start subtraction today. Now that we know about addition, we know about rational numbers or fractions and decimals, we can do subtraction, and then we'll start subtracting and adding them, combining all that together. And that's how we'll finish out the unit. Definition of subtraction. So if you were to try to explain subtraction to somebody who hasn't heard about it before, like a little kid or something, what would you say? The word subtraction is a vocabulary word. It should come up with a definition, some ideas. What is subtraction? What do you guys think?
You're taking something away.
Okay, great. So takeaway is one. Any other thoughts?
You're taking away the same, like, it's like addition. You can't take away something if it doesn't have it from it. So it's like the same quantity, you're taking away the same thing from it.
Yeah, they have to be like quantities. Okay, that's important.
It's the inverse of addition.
Okay, good. Good, so addition is combining, subtraction is taking away. Good. So those
It's
are
opposite. That's another word.
inverse, opposite of addition. Okay. So we're going to go over, let's see, 3 or 4 kinds. We're going to do 3 in our definition, then we'll add another one later. Subtraction is like a mathematical operation. So subtraction is a type of something. And so when I define, in math, I like to define things by saying what type of thing this is. So subtraction is an operation. You can identify like an octagon as a type of 2-dimensional figure. Okay. So it's a mathematical operation, and among all the mathematical operations there are, subtraction has certain qualities. So and that's what you guys named above. So it's a mathematical operation that finds the difference, or finds the difference between 2 like quantities. Yeah. Okay, so we have a difference, the idea of a difference. It finds, this is the takeaway part, finds out what's left over. or after removing or taking away? From like quantities. And it's also finding a missing or unknown addend. So you guys had these connections to addition as well, so that's good. Finds missing or unknown addend. Okay. Is everybody good with that? Any questions? So you guys know what subtraction is already. But trying to find different words or ways to explain some simple math topics is tricky. So that's good that we can have some language to talk about it. Difference or takeaway, inverse of addition, opposite of addition. It's doing those types of things. Okay, so subtraction is our topic. We're going to talk about parts of a subtraction equation. Just to recall though, what are the parts of an addition equation?
So you have, like with an addition, you have to figure out the two things that are like quantities that you're adding. So like the 2 plus the 8, and then you get the sum.
Okay, great. So we have different parts here. This right here is the sum, as you mentioned. Okay. What are the names of these two numbers in front?
Addends.
Addends, right. Okay, so those two numbers are either addends or summons. Okay. So that's what these ones are. Okay, and the answer is the sum. So it could be either one. For the first two numbers, I think usually people say addends the most, if they ever refer to those by name. All right, so because of that, we're going to ask, what are the parts of the subtraction equation?
So would it be the add-ins and the difference would be like the sum and addition?
Mm-hmm. Yep, difference is correct. Okay, so if I had an example equation of 15 minus 7 equals 8, this right here is the difference right here. The answer to the subtraction problem is called the difference. Okay. Now these two numbers here have like really funny names. Some of you might have heard them, I don't know. This one's called the minuend. And this one is called the subtrahend. Pretty cool, huh? And you can use those words if you want. People don't use them too much. But if you need to talk about the parts of a subtraction problem, you can talk about the first number is the minuend and the second number is the subtrahend. They do not have like names that are interchangeable because it does matter which way you subtract. You'll get a different answer if you switch the numbers, right? So the first number is the minuend. And in elementary school, the minuend will be the bigger number usually. We won't talk about too much of negative numbers where the minuend's smaller. So that's why it's like we don't use them too much, because we just say like the bigger number or the smaller number. So, but a lot of times we do use difference. So what is the difference in some sort of two quantities? You know, you use that word a lot. So if you ever come across reading in like teaching materials or whatever, they might refer to those as the minuend and the subtrahend. Okay, so we're gonna do our card sort activity, and I'm gonna try this I'm gonna pause this sharing for a minute, and I'm gonna try to do breakout rooms in Zoom. So I don't know if anybody's done breakout rooms before, but I have not as a teacher, so I'm going to try this out and see. Apparently we can break you up. I'm gonna break you up into groups. You guys can talk with each other and send chat or whatever, and I can go and visit your groups. Okay. So the activity that we're gonna do in groups is a card sort. I don't know if anybody's done a card sort before, but you have the cards in front of you, hopefully. They're downloaded, or you can just click on view from the course calendar on Canvas, the card sort handout. And we have 8 cards that we're going to sort into categories. So you have to read the card and read all the cards together with your group, or read them silently, and you got to propose which cards are like each other based off of the structure of the subtraction problem type. So they're all story problems, but they're like simple elementary story problems. So you read the story problem, and because of the structure of the story problem, you can pair them up. Okay, so they have each there's 8 cards, and there's going to be 4 different problem types, and so you've got to find those pairs. Okay, and you got to figure out with your group why those pairs belong together. What is this different structure based off of the subtraction? Because we have subtraction as a difference, we have it as a takeaway, we have it as finding a missing addend, and then we're also having the other category is, the 4th one is additive inverse. So, all right, and you might have some answers. You guys might might not be too sure about some of the things, so we'll take some time, maybe 5 or 10 minutes, and we can read and do this activity. We'll see how it goes. So I'm going to go ahead and does anybody have any questions about what we're doing? Okay, so we're going to go to breakout rooms, and I'm going to try. It says there's 17 participants in the Zoom chat right now, and we want to do groups of about 3 or 4. So 4 times 4 is 16. So I'll do 5 rooms. So do 4 rooms. Sorry, there's going to be 4 of them, and 5 in 1. So I'll do 4 rooms, and I'll do automatic assignment, which I think is that Zoom will assign you guys to random places. Then I'll press create breakout rooms. We'll see how it goes. Okay, so on my screen it had everything all broken up, and you know, click on open all rooms. And it looks like you guys can do that. Do your thing now. Join your room and go and talk with each other. Good, so we have Marley. Hopefully you can join your room. So Marley, are you there? Okay. So we got everybody joined in. Go ahead and see what they do in breakout room number 1.
Takeaway or finding the difference? Is that what he was saying?
Oh, here's Dr. B.
Yep. You guys are breakout room number 1. I'm going to check in with you.
Okay.
Which problem are we doing, Dr. B?
So there's a handout with
Yeah.
8 cards on it, A through H. You got to see which cards are paired with each other because each of them, there's 2 in the whole stack that have like structure for subtraction. Whether one's like take away, where I have some objects and I give some away to somebody else, or I have the difference between 2 like quantities. So somebody has some amount and some has another. Okay, so pair them up and write the letters together.
Okay, thank you for clarifying that.
Okay.
All right, so I'm going to go to other rooms and make sure that they're all clarified as well. So
Okay.
Okay.
you guys go ahead and have fun.
Look similar to, yeah.
Okay, you guys have any questions?
We were just talking about card A, and we were trying to decide whether it matched up with C or whether it matched up with H better.
Okay, good. So that's exactly what you're supposed to do. Carry on. I'm going to make sure that the other groups know what the directions are. So yeah, you just kind of sort them into pairs.
Cool.
Okay. Okay, how's it going? Questions?
Good. Yes, so our question was if we're just supposed to be solving them together, and then somebody else said that we're supposed to be pairing them together.
Yeah, don't solve them, just pair them by structure of the word problem. Some are going to be like takeaway, where we have like a certain number of objects and we give them away to somebody else. That's a takeaway problem. So look for pairs based off of the type of problem that's going on. Okay, so there's comparing, finding differences that way. So there's finding a missing unknown or addend, where you have your answer, but you don't have part of the addition part. And to solve that, you'd need to find the difference.
Okay, so there was the takeaway, compare, or unknown add-in.
Yeah, just trying to pair them. We'll name them all later. Just find pairs that are like each other. And go ahead and write down your letter pairs. Like card A we found to be like card H or something like that.
Okay. All right, awesome. Thank you.
Okay. I'll check in with another group, the last group.
All right, thank you.
Mm-hmm.
One have than the other?
Yeah.
Okay, I'm checking in with this group. Do you guys have any questions about what we're doing?
No, I don't think so.
Okay, so tell me about what you've done so far.
We're just starting.
Oh, you're just starting?
Well, we read them separately, and then we're all just kind of going over them now.
Okay, great. So I'll check back in a few minutes. Carry on.
I want to teach kindergartens, but I'm doing early childhood and elementary education. So I can do either younger or older.
Did anybody notice the recording thing just came up?
The recording thing just came on? I mean, like the teacher came into the room?
Nice.
Hi, Dr. B.
Talking about all of us going into teaching, Dr. B.
Oh, well, that's good.
Right?
Yeah, so in a normal class, you guys would have these chances to just chat.
Yeah,
and know each
I
other
know,
a
it
little better.
sucks.
Yeah, so it's like we're pretty far into the class already, and you guys haven't had a chance to do that.
Mm-hmm. That's okay.
But how's it going with the sorting?
I think we're done. Good. Yeah.
Oh, okay. Well, tell me what you got.
I didn't write mine down, but I said them. Sorry, I know A and C were a group. Did you guys write them down? I'm sorry.
So I got B and C. I think that's what we decided. B and C.
Yeah, B and C.
As takeaway.
And then A and D were find the difference.
Okay, yeah, I got A and D. finding the missing addend. Good. Carry on.
And then we have G and E.
G and E.
Yeah.
Okay. What is that? So we got finding the missing addend. We have finding the difference and takeaway, and then additive inverse. Okay. So why are those others put together? G and E, you said?
So we did A and D with
and
finding
D.
the difference.
Yeah. So A and D is those ones are paired together. Yeah, they were supposed to be anyway. And what was the next pair?
E and G.
E and G. So how are E and G that similar?
We were looking at how they had a total and they were trying to find what was left over.
Okay, good. Will you have a number left over with G? What would be the answer for G?
It would be
180.
180.
Yeah. What would be the answer for E?
0.
0. Okay, and those are like the differences, yes, but there's a special one for E that's not the same as G. So you guys do have a similar, there is a similarity between the two, but E is actually even more special than G.
Is it because they don't equal the same thing?
Well, E is special because it ends with 0.
Oh, I see. Okay. All right, then I guess that's where we misunderstood it because we were trying to pair them as similar questions. Like,
Yeah, no, you are supposed to do that, but
So would E pair with C then?
yes.
Okay.
Great. Now that part I didn't go over in my notes in the beginning. Why that's special is called the additive inverse, and I wanted to make sure I talk about that next time because I'm following somebody else's notes and they didn't put that in there.
So it's an additive inverse when they equal 0?
Yes. So you're finding what you need to subtract from a quantity to get 0. Okay. And we call that the additive inverse because addition and subtraction a lot of times are talked about together. Okay. So we'll definitely, I bet other groups will have that same question. Okay, so that will help you with your sorting. I'm going to go ahead and check with the other groups, see if they're done. And we'll let you guys know. I'll broadcast a message to come back together for everybody to leave their rooms when we're ready to come back together as a class.
okay. Thank you. Thank
All
you.
right. You guys can feel free to chat too if you're all done by then.
Okay.
Let me leave this room here. Okay, I'm checking in to see how everybody's doing here.
I think we got it. I was just wondering if we waited till the breakout room was over or.
Yeah, I will broadcast the message when everybody else is ready, but I'm checking in to see if you guys are ready to chat about your pairings. You guys have things paired?
I believe we have them
I think so.
Okay, so run down the pairs with me. That's what you guys have.
So we got C and E, and then F and
Good.
H.
F and H, good.
B and G.
Good.
And A and D.
Okay, great. All right, so hang tight. I'm going to go check with the other room, and then we'll come back.
I started out in secondary too.
All right, did everybody get a pairing? You guys good?
Yeah. Oh, are we only supposed to find one pairing or sit
No,
and like pair all of them?
All right, all of them.
Okay,
You
yeah.
got all the pairings.
Yes, I think so.
Okay. Did somebody say they were starting in secondary education?
I started in secondary and then I transferred or decided to change my major to elementary education, and then I transferred again to special education, severe special education.
Oh, okay. That's good. Finding your niche.
And I've worked in
Oh, sorry, Sid.
I've worked in all of them too. So I did an internship at a secondary math, and then I worked for an after-school program with elementary, and now I work for a severe special needs classroom.
Wait, hold on. You left secondary math? What'd you do that for?
I was in high school
Yeah.
when I did that.
Ariana, were you going to say something?
I was also doing secondary, but in the performing arts in orchestra. And I discovered really quick that I really enjoy playing in an orchestra, but I don't enjoy teaching an orchestra. And I couldn't handle all of the squeaking and the strings. And so I said, well, if I'm not going to specialize in music, I don't know if there's anything else I would want to specialize in secondary. And so then I went and interned in a third grade classroom, and I loved third grade. So I switched to elementary.
That's good. Yeah, I'm glad you're able to find out about the squeaky things before you graduated.
I just decided I didn't like trigonometry.
Oh, trig's fun though. That's good stuff. Well, okay, so all right, so you guys are ready to come back then? And we'll go ahead and I'll check with one more group.
There's just no filter. My little boys, yeah.
Okay, did you guys get all your pairings?
Yeah, we.
Okay, so let's go ahead and come back to as a class. And try to find out to close all the rooms and get everybody out. Okay, is that everybody? We have 10 now. Oh, okay, hold on. All right, so they should be all joining now in a minute. 30 seconds. Okay, so hopefully that was okay. Guys, as I was checking in, you guys are starting to get to know each other a little bit, which is great because that's what happens in a regular classroom. And appreciate your patience as we got back together. Let's go ahead and talk about the pairings that we found. Can somebody from any group throw out one pairing?
Aside from the ones we went over with you, or?
Well, there's only 4 pairings, so just give me one of them.
So A and D were the finding the difference.
Right. So A and D, we find the missing addend is what's called, where and so that pairing, what is similar about them? The story problem structure.
Well, they both talk about a whole number and then taking away something else and then coming to what you have left over.
Okay.
I don't know if I explained that correctly.
I think you're on the right track here. So they all started with a number. So you have one number. They had an answer. Okay. And these are addition problems because you're finding the missing addend. Okay. So you have one number, you don't know another number that you need to add together to it, and you do know your answer. You know the sum.
Mm-hmm.
In order to find missing addends, one way is to subtract off the sum from one of the addends, or vice versa. So subtracting off the addend from the sum, and you get the missing addend. Okay. And so I'm going to, let's go ahead and write down that, and I'll share my screen here with that. So one category is subtraction problem types. Yeah, so missing add-in stories is like you have an addition problem. So we'll take what Beth and her buttons. So Beth has 5 buttons that she needs for a shirt, but she only has 3. So we have 3 plus some number. You can do a question mark. And in elementary school, they do this a lot. Will they put maybe a box? Or will they put maybe a smiley face? Or something. Something that indicates the variable. But I'll put a blank right now for right now. Okay. So 3 plus some number is going to equal 5. Okay. So this is the missing addend. In order to find it, there's lots of ways to do it. We can do 5 minus 3 equals blank. Okay. So that's the missing addend part. We start with some number that we have a goal number, and we need to find out what the difference would be so we can bridge that starting number to the goal number. Okay, any questions on that one? Okay, so that's that one. Okay, let's have another pairing. So we have A and D are taken care of. What's another pairing that somebody found?
We found B and G.
B and G. Okay, so what is in common between B and G?
So he give you the amount that you need first. So if you want to do like equal 200, and then like, or you're taking that away to figure out your sum, to figure out the difference, I mean. And so with B, you're doing, Sarah had 8 rocks and then she threw 6 into the lake. How many rocks did she have left? So it's like the same.
Right.
You're just minusing 8 and 6.
So
then,
these problems, great. So these problems will have a start amount, and you're exactly right on all of that. Okay, these are the takeaway cards. You have a start amount, and you take some away. And then you end with another amount, end with difference. Okay. Excellent. Number 3, pairing number 3, what was 2 others? Okay. What about H and F? What is similar about H and F? You guys hear me?
yeah, I can hear you.
Okay. So H and F are finding the difference. Okay. What they're doing is that they compare 2 values and you can find the difference between them. Okay, so that's what's special about those. Okay, and those were cards H and F. Now the last one I didn't talk about too much. I didn't talk about really in the beginning. So a lot of people weren't sure about how to do these ones. Cards C and E are special. They're takeaway problems, but they're special because they are they end with the answer of 0. Okay. Oh, come on now. Go. Okay. So those are cards C and E. Okay, the answer is 0. So you have a certain amount, but you give all of it away. Somehow it's all taken away. And you end up with 0. So it could be any amount. So we have like 4, subtract some number to get 0. Now this number right here is special because it's called the additive inverse. All right, it's the number that you have to take away 0, which gives you the identity here. Okay, the identity is something that you operate on with addition, and it doesn't change the value. Okay. So you add 0 to any number, subtract 0 from any number, and it won't change the value. And so the additive inverse, that's the identity. The additive inverse is operating on your quantity to get your identity. So it's the number to operate on, the number to use to get identity. Okay. So if we talk about this in subtraction, because you can subtract to get to the identity to 0. We didn't do this in addition because we actually have to add a negative number to get to 0, but we won't do negative numbers really. So that's why we save this topic of inverse to the subtraction section. Okay. Any questions on the subtraction problem types? Okay, so the next topic here are called, once we know addition and subtraction problem types, we can now form the 4-fact families. Okay, 4-fact families. It's kind of hard to say because it's an alliteration, right? Or maybe some people like to say hard things to pronounce. Now, 4-fact families are derived from number bonds. Okay. Number bonds, as you recall, are like you write the number in like a box or circle, and you can branch them out with a visual graphic organizer. Okay, so to borrow an English term, you can graphically organize these relationships. So when you put 7 and 8 together, they become 15. Okay? You can do this with the picture. So when you have 7 and 8 together, so if you add these together, then you'll get to 15. What you can also do with the number bond is you can look at the subtraction part. So if you subtract 15 minus 7, you get 8. Or if you subtract 15 minus 8, you'll get 7. Okay. So the number bond itself is just the black part. I drew in some arrows to show the directions that you can look at. And what they do is that they with students doing these number bond activities is they say, okay, here's your number bond. You need to write 4 fact families. There are 2 parts to a 4 fact family. Part 1 is 2 sums. The 2 sums that you can get from a number bond, and they're commutative. Okay? Seven plus 8 equals 15, and 8 plus 7 equals 15. Now it's important for students to know the number bonds, or one thing that you get out of their number bonds that's important is the commutative property and these addition facts. Okay? So when you relate them together, you can derive addition facts and subtraction facts. So part 2 from a 4 fact family are 2 differences. From the number bond. Okay, and those are 15 subtract 7, like I showed before, that equals 8 in green arrows. And then you can also do 15 minus 8 equals 7 in the red arrows. Okay. So those are the number bond. Those are from the number bonds. Those are the 4 fact families. Okay, as another example, I would like you guys to create a number bond first. Number bond and a 4 fact family relating to the number 13. Okay? So first you create the bond, and then from the bond, you derive the 4 fact family. Okay, so I'm going to stop my share here so I can see everybody's work. So once you do that in your notebook, go ahead and show it up to the screen, and I'll call on some of the people that have showed their work. You want to create a number bond. And a
Are we
4 fact.
creating it with any numbers?
Yeah, any numbers, but you have to have the answer of 13.
Okay.
Okay. So the beginning number in your number bond should be 13 with the circle around it. You break it up into 2 different numbers, and that could be any number. Oh, let's see here. Nicole's got hers. Okay, go ahead, Nicole, and tell us what you did for your number bond, and well, actually just go with your 4 fact family.
Okay, so I did 6 and 7 for my numbers to equal 13.
Okay, pause. Other people who have done 6 and 7, thanks, Camille. You can go ahead and follow along and make sure you double check your work. Okay, thanks, Sid. Go ahead, continue on.
So I have 6 plus 7 equals 13, and 7 plus 6 equals 13.
Great. That's 2 of the 4 equations for the 4 fact family. So what other equations did you write down?
So then we have 13 minus 6 equals 7.
Mm-hmm.
And then 13 minus 7 equals 6.
Okay, great. And okay, so the concept of 4 fact families is not too complex because we're working with elementary math, but it's important to know what the vocabulary words are: number bond and 4 fact family. It's an arrangement of the facts in a way that you probably haven't seen or done since elementary school, or worked with even during your years of elementary school, but that have been kind of catching on more nowadays with math education. Okay, so great. So notice the time, we got about 12 minutes, so we're going to move on. Thanks for all those who have worked on a 4-fact family. And I'm going to go ahead and share back to my iPad. The last topic of our course, our class today, is ways to subtract numbers without knowing any particular algorithms. Okay, without knowing rules, they call it. So ways to subtract without knowing rules. Okay, so we're going to present 4 ways to do that. Okay, and this is going to be our example problem through these 4 ways. We're going to subtract 37 from 75. So we're doing 75 minus 37. Okay, so way number 1. This one is called compensation. When we compensate in addition, we look for the tens complement. Okay, we look for numbers to add on to make a nice even 10. That will help us do that. In subtraction, we do that as well. We're going to add something to make the second number a 10. So the subtrahend, the second number subtrahend, we're going to make that a 10 complement. So we're going to compensate to do that. And that'll make it easier to subtract from the minuend. And I'll show you how this is done. If we added a 3 to 37, okay, if we added a 3 to 37, then that'll make it 40. And that would make it easier to subtract from the first number, the minuend. Now, why does this work? Why can we do that? And what do we have to do to the first number? In addition, we had to subtract 3. Okay? If I added 3 to the 37, I needed to subtract 3 from the first number in addition. But in subtraction, you don't do it. This actually works the opposite, of course, as one might expect. If I added 3 to 37, I would also have to add 3 to 75. Remember that subtraction is a difference. Okay, and so I'm going to show these numbers on the number line. Okay. And I'm going to draw in, let's pretend that this right here is 37, and this right here is 75. So if I'm going to add 3 to 37, I'm going to jump from 37 to 40 by adding 3. Now the difference between these two numbers needs to be maintained. This distance right here on the number line between the green tick marks has to be maintained. And if I add 3 to 37, I'm shortening the distance from 37 to the 75. And thus my difference will be different. And if my difference is not the same, then it's not the right answer. So what I need to do is I need to compensate by adding 3 to 75 so I can maintain the difference. So if I add 3 here, to get a new number with the blue tick mark, okay, then the difference is maintained. The distance between 37 and 40, or 37 and 75 in yellow is going to be the same distance as 40 and this number in red, okay? Notice that red and yellow make the same distance on the number line. So the difference between the two numbers is the same. And so what is that number from 75 and 3? 78. Okay, so pictorially, that's what's going on. Another arrow there. All right, so numerically, what can we do? Well, you can take your 75, subtract your 37, and you can show the compensation by adding 3 and adding 3 to the top number and the bottom numbers, the minuend and subtrahend, and then you get new numbers. Whoops. Usually diagram this with one arrow. I now have my 78, subtract 40. Okay. Because of that adjustment in the numbers, the subtraction is much easier. Well, according to the algorithm, I would have to regroup here, make that a 15 and make that a 6, right? But when you add the difference, when you add a little bit to the bottom number and the top number, then you don't have to do any regrouping. You don't have to break up things and pull things from the tens. Okay? You can just subtract. So 8 minus 0 is 8, and 7 minus 4 is 3. Okay? So that's what's good about compensation. You add a little bit to the bottom number and to the top number. The compensation can be done with subtraction as well. So I will show you, so this is a big OR here. And I will show you that with this number line, here's 0, here's 37 again, and here's 75. I can also take away from each of the numbers. Now these numbers were constructed so that you could add something nice to them, but I can also take away. So I can take away the same amount. Let's subtract off 7. And then I end up with 30 here, okay? So making my subtrahend a power of 10 by compensation, we can make things easier to subtract. So I subtract 7 from here. This one makes it a little bit trickier, but 75 minus 7 is 68. So we'll go ahead and write 68 down. Okay. And the difference, notice that the difference is maintained from 37 to 75 in yellow. And my new numbers, 30 and 68 in red. Okay. Difference is maintained. So what I did numerically, 75 minus 37, is I subtracted 7, subtract 7. Then I have 68 minus 30 gives me my 38. Okay. So that's the compensation. You can take away from two numbers, or you can add to both numbers, and you'll make the problem easier. You can do subtraction that way.
I just had a quick question.
Mm-hmm.
So just to clarify, where you got 3 and the 7 from, it was just to make that so you would have a nice round number, but you don't have, that's how you determined what number to use?
Yes.
Okay.
Good question. So I wanted to have a nice number as a second number, because when I subtracted it right here, I only had to worry about tens, and then I didn't have to do any regrouping or unbundling or borrowing or whatever.
Okay, that makes sense. Thank you.
Mm-hmm. Okay, so way number 2 is breaking up into easier numbers. So just like we can do with in our 30-second challenge, we did that with multiplication and division. Breaking up to do subtraction is helpful. Okay, so this one's called breaking up. You break up into easier numbers. So our 75 minus 37 could be broken up into, you can look at powers of 10. I'm going to do 60 plus 15 because I'm going to take away 7 from 15. And if I did 70 and 5, I couldn't take away on the ones. Okay, on the ones column, 30 plus 7. So if I break away those up in that way, so this is helpful if you do have maybe something to write with here. So 60 plus 15. Subtract my 30, subtract 7. If I'm trying to subtract a quantity here, this is key. I'm subtracting both of these things here. I need to subtract them individually. Okay, and that becomes minus 30 and then minus 7. I'm going to group my 30 with the 60. And you can commute subtraction if you keep the number, the sign in front, but otherwise you can't do it. And keeping my sign with the in front with the 30, I can go ahead and do 60 minus 30 and get 30. And then the associated property says I can do the 15 minus 7. And then I get my 38. Okay, so way number 2 is breaking up. It's a little bit more complicated because I broke it up into funnier numbers, but it's one idea. Way number 3 is called counting up. Sometimes people call it the cashier's method. Because if you pay for something, let's say that something costs $5, and you only have a 20. What the cashier can do is that they can start with the $5 price, count up, and hand you change and bills until the 20 is achieved, okay, until you get to 20. So they could start with $5, then they add on $5 more to get to $10, and then they count up to give another $10 to get up to $20. Okay? So the answer will be these right here of the change, the difference. So this is called counting up. So you can find the difference by counting up from the smaller number to the larger number. This is kind of like the missing add-end thing. Okay? So the cashier is thinking, well, $5 plus what is going to equal $20. Okay? So counting up is missing add-end. Notice that if I go back to my number lines, let me go ahead and draw new ones, sorry. I'm going to draw a new one. Okay, so 0, and this one was my $5. This one's my $20. Okay. I'm just finding the difference, not going back this way, 20 minus 5. I'm starting with my $5 and seeing how much it takes to get up to 20. Okay, and I stopped at $10 along the way. Okay. So 5 plus $5 gives me the $10. $10 plus $10 is 20. Okay. So that's, now that you know what the, kind of get the idea of what a cashier's method is, let's do it with our problem example. Okay. So we're doing 37 up to 75. So 75 minus 37. I'm going to start with 37, and I'm going to go to 40, because I'm going to do nice numbers first. So I'm going to add 3 to do that. And then I'm going to go from 40 up to 70. Okay. And to do that, I'm going to add on 30. And then from 70, I can go to 75. That, and I add on 5. So this whole thing right here is the difference. And so I add those up and get that the total difference is 38. So that's counting up. You guys good with that one? So we got like -1 minutes in our class. So if you guys need to leave, that's fine. I'm going to do the one more method for just another minute. Wait 4. This is called subtracting tens and ones. You want to keep the total in mind when you're doing this. Okay, so you're doing this with keeping the total in mind. So with 75, subtract 37. I'm going to do, in my mind, I'm doing 75 minus 30. So I subtract the tens first, or the highest value. Okay, I'm subtracting tens, and then I'm going to keep the answer, which is equal to 75 minus 30. So I'm subtracting off the 10, so I really just thinking about the 70 minus 30. But 75 minus 30 gives me 45. Okay. And then I'm going to take the 45, and I'm going to subtract off whatever the ones were, which is what's left from the 37. Okay. And when I do 45 minus 37, all I have to do is think about the 15 minus 7 part is equal to 8. Okay, which means that I take off the 110 from the 4 and make it 3. Okay, so 45 minus 7 is like 15 minus 7 being 8, and then that taking off that 10 from the 4 to get 3. Okay, so that's that one. Any questions? That's all I have for today.
Dr. B. Oh, sorry, Camille.
Go ahead. I was just saying no questions. Thank you.
Yeah. Melissa?
I was going through the syllabus and it was saying, I was trying to make sure that I had everything right when it comes to the 30-second thing, because I know it's optional when we do it on the app on what we choose. And I was a little bit confused on, sorry?
Go ahead. You were confused on what?
I was confused on if we had to do specific problems based off of the lessons.
Oh, no, you don't. You can do anything you want there. What I
Okay,
would do
perfect.
is
I was like, we're coming pretty close, so I didn't want to do all of that and then be wrong. And I also noticed that the final exam is set up a different way. So if we get certain percentages in categories, is that per chapter or how does that work?
It's not per chapter. It's going to be, we have, I forget, they call it learning outcomes. There's 5 like types of things we do for the whole course. Like fluency is one, algorithms are one. And so all of the problems from all of the tests on algorithms, for example, we will put into a category, and you have to get 70% of those problem questions correct in order to pass that section. So those are strands that go through the whole course. Our course will study addition, subtraction, multiplication, and division, but we'll also study various things in there. Like algorithms is the one that's easy to know and talk about. So after I grade the first test, then you can kind of see how the percentages are gonna start stacking up.
Oh, perfect. Okay, because I just wanted to make sure as far as like what the things that, because after the first exam, we'll see what we need to work on individually then and bring up those percentages, I'm assuming. Okay, perfect. Thank you.
Yeah, so I'm going to try and have, on each exam, I'm going to try and have several problems from each of the sections so that you can, not like have one section outweigh another.
Okay, perfect. Thank you.
Yeah.
And Dr. Broderick, when do you think like our exam will be graded, this first one?
So I'm going to do, I have a couple errands to run today. And then when I get back this evening, I'll grade the rest of the homework from grading from chapter 2. No, I did grade all of chapter 1. So yeah, exams first, and then grade chapter 2 homework that you've done so far. So that's my focus today. Okay, yeah, thanks for you guys' patience. Any other questions? Okay, if you guys have any that come up later, feel free to send me an email.
I have one. I was just waiting for everyone to go.
Oh, okay, yeah, if you have it, if anybody else doesn't have one, then does everybody else have a question for me and that student?
Okay, have a good day, guys.
Okay, bye, Melissa. Lindsay, do you have any questions? Lindsay, are you there? All right, I ended her. Okay.
So I told you that I had gone on vacation. Well, sort of. I went to that graduation.
Hold on, let me